Good morning. Hope everyone's doing all right. Let me get started. Get my phone set up. Slept in a little bit. That's good. Trying to shake some of the stress of life. Believe it or not, this is one of those things I do that helps me focus on something fun. I do enjoy this. Pull up my chat. Apologies if anybody's beating me there. Nope. Room's empty. That's all right. DBC. I don't know if DBC is actually there or if it's just a ghost of DBC. Like, DBC is just in chat, not actually viewing. That's fine. Gonna get my little preview window up. And then let's fix the browser. Go black for a moment while I fix it. There we go. Go back to regular. So we're gonna try to figure this thing out. How could this happen? I didn't touch this since we last saw it. Basically the error is that reconnect happened and set player initial location was called when a player didn't, well, when they already had an initial location. If we look at this on line 96, let's see. On 96, we call set player initial location. That's fine. Try to figure this out. Load actor. Some future stuff here. Game master load actor. 49. Closure. See. I like these little gray ones here, like self the load actor. That's kind of useful. What's going in here? We have game master, load actor. $49. So there. That goes to line 80. You're going through here. 80. This point. And I think at this juncture here, the load actor connect is because when we took him out of the linked dead timeouts, okay, so we take him out of the linked dead timeouts. Oh, no. That means that they were not in linked dead timeout. So if they were not in our queue of things to time out, but they were still in ECS, that means we've got a hole somewhere. So somewhere we've got a situation where somebody can get disconnected or added to ECS without being in this. Interesting. All right. Well, you could just do a code crawl. Let's see. Try to reason through it. Something else that's kind of on my mind. Got a goat that's about to give birth. Starting to isolate herself from the other goats. Stands in place, staring into the distance. Her sides move independent of her. Like there's something inside. It really is a little disturbing when you see that. Like, wow, what did you eat? But no, about to give birth. Rather, I really hope she's about to give birth, because if not, that's some sort of xenomorph there. Alright, so at this point we have linked to timeouts, and we have ECS. And somebody's in ECS, but not linked to timeouts. Did we get two connections? Did the connection just not die? Guess I should guard for that. Oh, come on. Oh, full screen. Page up. There we go. That happened. We should be able to see that in here somewhere. Stream ID 2. Getting linked into the zone. Incoming message from stream ID 3. So let's see where that is. So this is where connection died. Packet 255 linked dead. That's kind of an internal packet. Getting linked dead timeouts. Getting player zone for announcement. Getting player zone for announcement. This should have removed them from the ECS. Unless, of course, the ECS isn't committing that right away, which would be bad. let's search the text for that. So we have that there, and then so between those two log lines, which I'm glad we didn't remove yet, we remove player zone and connection. If that's the case, somewhere, let's take a look at this. It's A. We're going to set a marker there for A. Because between those two log lines, between these two, they should have been removed. Unless, of course, there was yet another connection. That's stream ID 3. Oh, yep, here again. Zone 4. Okay, let's go down to where the error happened. Okay, yeah, we were too far up. Too far. I think what we saw was a good situation. Have a look at this. Here we received none. Where's the link to info? Okay, that's why it went into the wrong direction. Stream ID 5. Received none for something. I don't know which stream that's for. Error 0S code 54 connection reset by peer. Oh, interesting. Incoming error connection reset by peer. So if that happens, we didn't handle that case where it wasn't a graceful shutdown. If we go to Game Master, lib, should have some like run Game Master. Oh, where is it? Is the wrong file? Yeah, it's not in there. Game Master lib. This is in server lib. Run Game Master. So now for channel change. Here we have graceful. But in the case that it wasn't graceful, we don't filter that. That means that it got converted here? How did that get converted? What was the packet? Kind 255. So it did get converted into something. Does that mean that it came through here and no, because this is for incoming message. I guess those are all incoming message. Incoming packet, message, incoming packet. Huh. Does that get filtered out before this? One game master? No, this is it. This is... I don't think we have any filters where that's called. Yeah, there's nothing there. So go back. Oops. Go back. Lost where I was. Go to Run Game Master. So what happens if something comes through that we're not handling? It looks like stream disconnected for non-graceful reason not being handled. Let's just make sure that's how one of those comes in. Quite frankly, I haven't tested that at all. Not even sure how to reproduce that. We could try making a test for that. Let's make a test for that. After we look at this. So disconnect reason, it just has, oh, graceful or channel change. What is incoming message then? Oh, value. It's an incoming message. The value is an error. It's an IO error. I should have paid attention. Where is it? Incoming error, dropping stream. Okay, that should be handled with disconnect. Find connection reset. All right, I think we have enough at this moment where we can reproduce it. Go to link dead test. Let's rename this to graceful link dead. And this is IO error link dead. So instead of us sending disconnected, it doesn't seem like that's actually happening. Where does send disconnect happen? We're gonna fast forward on this one. A little sharp right now. It's not in the mood. All right. So to reproduce this, what I'm curious here is if that, why didn't the send disconnect not happen? Send disconnect with reason. down here. To me, this doesn't really feel like a an error in the game server. It feels more like an error in Stream Multiplexer. Because we should have received this after we received the IO error, or rather the IO error should have been converted into this on its way out. Because we got connection reset. Let's double check and make sure we didn't get stream disconnect. No. Yeah, and here's stream 5, and then we have somebody connecting as stream 6. Okay, that looks like a stream multiplexer error. So stream multiplexer is a crate that I've been working on. I am surprised that didn't happen that way. Okay, looks like we received none from stream multiplexer, but we also had an IO error. Let's see, where do IO errors come from in stream multiplexer? Oh goodness. We look at the top level stream multiplexer. Basically what happens is that you end up giving it a codec that can produce things. Or, excuse me, what are the words for this? Let me just show you. That codec, it's in codec. So you end up having a packet, like a producer of connections. And that's not here, it's where this is actually used. Use this in here. So essentially, what Stream Multiplexer wants is something that produces a stream of write half and read halves and might produce IO errors. Okay. What happened here though was that when it did produce an IO error, maybe not, yes. I think it's that the read half or the write half actually produced an IO error, not the stream producer though. Because the write half, I'm sorry, I'm not explaining it very well. I'm thinking through it without explaining it. Stream multiplexer takes a stream producer. Okay. Something that when it's a stream and anything that can produce basically an async read and async write and be can use stream multiplexer. It could be like UDP packets or maybe a Unix file system, like a Unix pipes, that sort of things. I'm using it for TCP streams. Now, these read and write halves though, look at those themselves can have errors. Steph and Game Dev, good morning. How are you today? It's late where you are, isn't it? walk to the beach, saying 1.5 feet from other people. Corona rules. Oh yes. Oh, it's only 4 o'clock. Okay, that's cool. Sounds like a nice day. Packet codec. Let's see. We have our own state. It can do different things. I think this is supposed to implement decoder. Yes, and that's where the IO errors can come from. Okay. What am I working on? Sorry, I'm at a Discord server now. Huh. There are too many people asking to ignore now. Oh wow. I'm actually working on actually fixing a bug in the game server. Basically, in the game server, when you go link dead, you should be able to come back into the server. The problem is, if you don't go link dead in a graceful manner, let's say you go link dead in a kind of a system IO level error, like a connection reset by peer, that sort of thing, it doesn't work right. So there's a bug where we're not handling this case here. And it looks like it's one of the dependent libraries that I use. Happens to be a dependent library that I wrote. So I'm going to go fix that in that dependent library, that it still produces a disconnect message. Just trying to figure out where that happens though. So I'm working back from where the error originates, and that's in packet codec. Packet codec is on a read and a write half. The read and write halves are produced by TCP stream producers. So my stream multiplexer crate over here. If you click on docs, you can see that there's actual documentation there. But essentially, the stream multiplexer takes one of these stream producers, and that can be like TCP connections, things like that. And as data comes in, it can efficiently multiplex it into a single connection. Basically, all the data that comes in off of, let's say, 1,000 different connections, it's piped into one connection, one stream that the game server handles. The reason I do this is so that I can have different kinds of back pressure. So if somebody's not authenticated, they're in a different queue of back pressure than, let's say, the game server, which might have a lot more resources allocated to it. So I used to say it's like, I'll continue to say it that way. But it's like a party, right? Where the party's full and you can't get in. You need to make sure that there's back pressure and people can't actually get into the game unless there's room. And that's why stream multiplexer was created. Very complicated way to actually do that, but it lets me do back pressure correctly in Rust. Because I had been doing it wrong before. Let's figure out where this happens in game and stream multiplexer. Let's see, if we look at multiplexer starts up. Oops, I don't want to change that. We're already in multiplexer. Multiplexer has a number of things. It has features unordered. This is where all the data is coming in from. Big set of kind of a read half of those TCP streams. My daughter was asking for the internet access on the computers. So we'll see how this goes. So here we have a large stream of TCP read halves, right? And if there's an error that comes in off of this, and it's going to cause the connection to be dropped, we should handle that. One of the little hints that we had in our error was that incoming reader received none. I think that happens in a couple places in here, and that might get us closer. It happens in one place here. But this is nowhere near where we generate those graceful disconnect messages. It's where we generate those. It's in halt. Which function is this? Halt async read. Interesting. One of those detective jobs, yes. So this is in the read half side of things. Async halt read. The problem is what here then? How can I actually simulate this? I have a whole bunch of tests for this. I'd like to be able to create another test case for this to make sure we don't break it in the future. And currently I use things like actual TCP streams to simulate this. Wondering if I can use something else that can produce one of those messages. If we get an integration, a bunch of different elements in here. Socket shutdown, null change, link dead. Link dead is supposed to be working. I think it does because we shut down in a graceful way. So here we spawn multiplexer, connect to it. We make sure that we get stream connected and disconnected graceful messages. But let's see if we can reproduce this error here. Fix it. It's a big question though, is how? Link that via IO error. So in this case, we call client1.shutdown. We shut down both halves of it. What am I using for my TCP stream producer? Okay. I think I need something that can, instead of a link to the limited codec, something that I can inject an IO error into the actual stream. Does Tokyo have test stuff for this? Let's check. Let's check if Tokyo has test elements. Tokyo test. Oh, that's a macro. Is there a Tokyo test? Back to crates. Oh, there is. Go to that documentation. Mock type implementing async read and write. Oh, lovely. Provides a type that implements async read and write. Can be configured to handle arbitrary sequences of read and write operations. Oh, this looks perfect. Build mock instance. Oh, look at that. Built with handle. I wonder what this is. That's neat. What about task? On a mock task. Features spawned on a mock task. Huh. Okay, it looks like the piece that I want is really the IO stuff. An IO object that follows a predefined script. Created by builder and implements async read write? Yes. Okay, so these things do allow for IO result, standard IO error, so we can return an IO error from this mock object. Okay, good. Let's get this crate added. What is it? Tokyo underscore test. Cargo add Tokyo underscore test dev test. Get that and get it built. Okay, now we're gonna have to figure out how to use that. While that's building, actually this. Insert error, okay. I see, and these are for the poll operations, which I don't think we need to use any of those macros. Insert error and okay is nice though. Now what is handle? So we know that builder creates a mock IO object, but handle here, handle to send additional actions to the related mock. Oh, I see. So depending on what's going on, you can actually, it's like puppeting it. They can react to certain things. So that's neat. Okay, which is probably also coming out of builder. I think I saw in there, build with handle. Okay. We'll have a builder, an empty builder, fine. All right, now how are we gonna work this into our tests here? We go back to our tests. We have a TCP stream producer. It takes a socket. Oh, I see. So maybe we produce a test test listener that can produce certain kinds of mock objects. That'd work. Instead of doing an actual bind, we can actually just pop it the whole thing. Nice. Now our TCP stream producer, new. This one's a TokyoNet TCP listener though. Maybe we just do a test one. Test stream producer we could build pretty quickly. A way to have our little builder generating stuff here. We'd probably want to pass that in, like what is the next thing? Or you know what? I mean, this is just. We might be able to just build it around a MPSC queue, something like that. Just toss a channel in there and done. So instead of it being a TCP stream producer like this, it'd be some sort of MPSC queue, and then we could give it mock objects that it then returns. Oh, nice. I'm gonna just copy this file. Oh wait, this is in stream producer. TCP stream producer. Interesting. Let's make another one. Let's create a directory. No. Lowercase d. Mock. Well, the mock stream producer. What is it? $sign there? No. Percent? Yeah. Mod.rs. There we go. Use this as a starting point. TCP. CGN mock. Skip that one. Mock. No, we're going to change that. TCP stream isn't correct there. Okay. Now our inner here, I think it should just be a MPSC queue. And it's going to be an MPSC queue of whatever those builders return. There should be Tokyo test IO mock. And it implements those elements. Okay. So we're not going to be doing the splitting here. Oh, I guess we can split it, can't we? Because it implements async read and write. So it's really this piece here. All right, let's try. MPSC receiver of mock. Let's get those imported. Use Tokyo test IO mock. That one is. Use Tokyo sync MPSC. Somebody's going to create the channel, give it to this thing. A regular MPSC, a receiver, it's not an unbound one. There we go. What does this take? This takes a Tokyo sync MPSC. Tokyo test : IO mock connections. Okay. This is no longer a TCP stream. Both of those become mock. That should be okay. Now this part here. Poll accept. Where does poll accept work? What does the analog know where we're going? Let's figure out where we were. Poll accepts on a TCP listener. All right. I think we're just going to call next on a TCP stream. Excuse me, on the receiver. Tokyo. Implement stream. And we need to call poll next. So this is the analog here that we need. Okay, back to the code. Yes, and that also takes a context, and hopefully that will work. We split the stream, everything else works. Wow. Actually, I wonder, these are so close together. I thought they recently added stream to Tokyo's IO stuff. Let's see. IO mock. Go to Tokyo. Documentation. TCP receiver. Oh, this should just be Tokyo. Okay. Modules. That TCP listener, that's it. So now I have a stream on this as well. wonder if we can combine these two. They are so close. Let's go back to the other one for a moment. Stream producer. And instead of calling it a stream producer, maybe we just call it a test stream producer. This is very specific. It's a length delimited stream chunk stream producer. Okay, let's change that to test. We'll have to work through this. Okay. So instead of that, we can say we're going to take a T, okay, and we have to constrain T. T. We technically don't have to do that yet. Inner T. We'll have to constrain it on the stream. Just down it. Async read plus stream that produces async read and async write. Oh, right. Fix a stream. While producing, whatever. Okay. So then in here, we have to know how to use that streams item as the result type there, result of TCP stream. I wonder if we'll be able to do that. Where T is stream. And I guess what kind of stream? That should have a pull next on it. 15 these, okay. And future stream should have pull next. Let's see why it doesn't have pull next on it. Futures stream does have pull next on it, but it only has pull next probably on things that are more constrained than this. Okay, that seems fine. But this is what I'm more concerned about. Here, we need to be able to get the internal half of that. U. Oh, what is it? T colon item. No, we can't do that, can we? How do we get the type out of that? So the problem that I'm trying to think through is that a TCP stream has something with has an item, and the item in this case is a result, and the result has some other type. In this case, it's a TCP stream and a standard IO error. So maybe that's it. Maybe we can just say, you know what, we can take a stream as long as it produces a result with a thing and have a U here. Let's go to the big error. Cargo check. Will that check the test as well? No. Can I say what to check? Test. Tests, plural. Okay. Seriously? Compiler disagrees. Just the fact that, was this test? No, is this not even used? That's a bummer. What is integration test using? TCP stream producer. And where do you come from? Nowhere. Oh, I wonder. Source, we're in the wrong directory. I'm a little relieved to find that we're in the wrong directory. Much better. Right. Integration should be failing right now because TCP stream producer doesn't exist. That's expected. To fix that. Test stream. Oh. Yeah, I think I got all of them. Good, down to this one. No poll next found for that in the scope. Perhaps you need to restrict type T with it. Ah, that's a great idea. Like this. Oh, does future stream not actually exist like that? It does. Let's double check on that though. Future stream. Looks like it's just re-exported at a different place. That shouldn't make any difference. Okay, it didn't make any difference. And pull next is there, but maybe we have this element wrong. I'm guessing it's the pin. Probably need to pin it. Let's double check. Pull next. Self, pin self, and the context. I think we have context already. Isn't there a pull next pin? Let's check the browser again. Pull next unpin. What does that do? Let's look at the code for that. Scroll to the top. Source. Pull next unpin. So it pins self and pulls it. We can only do that if self is unpinned. Got it. And what was that on? That was on StreamExt. So that trait needs to be in scope. So first, let's pull that into scope. Use future. Oh, it's in my clipboard. Okay, and T has to be unpin. Easy enough. Plus unpin. Nice. Of course, the return type's wrong, all that. We'll figure that out in a moment. Just gonna check the return type on that. So yeah, it's pull option self item. So that returns pull option self item. Now convert the error to standard IO error. Question mark. Let's see, performs conversion from trait. Standard IO error is here. Our item is a result of that. But ready is supposed to not unwrap it as far as I want it to unwrap it. So here, this should be an option. We're not going to unwrap the option. So let's check on that. Yeah, so this macro, it returns immediately if it is pending. And if it's ready, it just returns what's inside of ready. In the case of pull next on pin, so that pull, that enumeration might be ready, it might be pending. That's fine. But what's inside is that option. Oops. Thank you. Is that option. So let's get the option back. And if the option is none, we'll return none. We're going to unwrap that. Back to the code. And if you have any questions, let me know. Probably qualify that, but whenever I say stuff like that, I like expect somebody to be like juvenile. Anyhow. In this case, let's actually match on that. Match. And we're going to get a none. What do we do with a none? I don't know yet. If we get a sum, we're going to do this stuff down here. Uh-oh, deleted too much. In the none case, we return already none. No, already none. Okay. Yes, and this is where we need to add more constraints to that. It's fine. Also, these elements here should be of type U. And we need to make sure that U is constrained. I think, let's see, we need async read plus async write. What else do we need? Oh, those need to be in scope. Guessing that's where they are. Async read is not implemented for result on that. Oh yes, we didn't unpack the result yet. So if this is okay, do this, it's some error, we do something else. Already some error. Expected enum result. Error. Okay. That is surprising. Line 3. Don't need stream. Wow. Gotta be kidding. For a test. Well, that's good. All of our existing tests work. Let's go play around with that. Let's make that mock test. Oh, we have to do a little cleanup first. Mock stream producer is no longer needed. Wow. All right, now to finish up with that, let's get those tests. Integration. At the very bottom of this, we just cloned the other test. Now in these cases, we're actually, in the other cases, we're using actual TCP, like listener and sockets to connect to it. The OS is quite involved. But to do what we want to do here, we're not going to be able to do that because we need to produce an I/O error. And I can't just poke the OS and say, hey, please inject an I/O error into the stream. So instead of binding to a socket, we're going to create an MPSC channel. Let it be a mutable, say, producer TX, mutable, need to be mutable in this case. Producer RX, we'll give that to them. MPSC, this is going to be a Tokyo Sync MPSC channel. So you can have up to 32 elements in your buffer. I don't care. That'll never happen. We'll say 2. Maybe, yeah, two's fine. That's that. Local address, that goes away. User RX gets that. Sing. Use Tokyo Sync MPSC. Oh, as channel. Yeah, back when I did that. Okay. Channel. Yeah, and this stuff here is not going to work. So now we need to inject a mock stream into that. So then they should just behave normally. Connect, it should disconnect, and that's it. At 1 equals Tokyo test. The Tokyo test builder. Over here somewhere. Tokyo test. Oh, IO builder. That's cool that you can do weights. I don't know if I can actually do what I want with this. How do I shut it down? Hold on a sec. I need to check my network. Alright, I'll keep going. Seems okay. Kind of okay. Yeah, I'm getting like 6% frames drop due to network stuff. Let me know if it becomes an issue. Oh, there we go. Fixed it. And suddenly, network goes out across the house. Alright. I'd say give us like 2 minutes. The kid's going to be coming into the office. Tokyo test IO builder new. Yeah, because how do we actually make this like cleanly disconnect? What does a clean disconnect look like? Guess it's a what does that look like? Seriously? Something. Something on my network is chewing up a lot of data, and it shouldn't be. Everything is pretty much just turned off right now. Yeah, it says I'm uploading and downloading a bunch, but I have nothing listed that's actually using that much data. Oh great, I think my network was trying to update itself. Oh, it's still not happy. Bummer. Yep, upstream's good. That's so strange. All right, let me check. I'm guessing something has decided to update itself around here. This has nothing going on here. This one's good. Check my other machine. Oh, you know what? I'm gonna kill Slack on that box. Bye bye. Strange. Chrome might have just updated itself. Yeah. Okay. Thank you, Chrome. I didn't actually turn off auto updates on Chrome. Anyhow, back to the code. Okay. So if we're going to build a new one of these, how do we actually signal that the stream is empty and the stream is done? Let's see, if we go to the browser, I think how we end up signaling this is that we have to signal it through a number of things. And one of them is that there's no data to be read. If we signal that there should be a read, and the read operation is basically nothing, there should be nothing, then that should be fine. Hold on. What did we just build? We go back to Stream Producer. This thing wants stream that produces results for you, and you in this case is async read and write. Now this already worked for the existing tests. Hey, Dr. Cringy, how's it going? So in this case, we split the reader and writer, these two elements. So we're actually fixing stream multiplexer so that it can handle I/O errors. So if somebody gets like a connection reset by peer, that sort of thing, stream multiplexer doesn't handle that at the moment. So I'm trying to think through the process of a TCP stream. When the TCP stream is working normally, it comes in through here. We have a new connection. It gets split into an async read and async write. That's fine. We wrap it in a length delimited codec, which is a framed reader. Excuse me, that's a framed writer there. And then we have a framed reader down here. Now, how does a framed reader and writer know that an async read and async write are done producing data. Oh, that's not going to be here. Let's go to standard lib. Async read is what? Tokyo. Tokyo IO async read. Okay. This means that the poll ready function will return one of the following. Okay, n means that n bytes of data were immediately ready or immediately read and placed into the buffer. Where n equals 0 implies that end of file has been reached. Okay, that seems doable. And error, there was an IO error. I don't know how to produce an IO error for this case. I might need to wrap that other async read stuff. Oh. Because here we can say, we can give them a buffer that basically has nothing to read. What does this do? He wants to read to the buffer, self-tx send, yada yada. So yeah, in the case where we have nothing to read, we just give it an empty array. Return the number of bytes read. I see. Okay. On the grind, yes. Oh shoot, you're in the browser. I was looking here. This is read. We give it a buffer and they read n number of bytes from it. Figure out how much to copy, and it's going to be equal to whatever the length is, the destination length or the other length. Okay. So that should be like a normal shutdown, but then how do we do like a... Oh, sorry, I was still looking at this. So if we do this and give it 0, that's a normal shutdown, but how do we feed in an IO error? I don't see any of that in what we built so far. I mean, we could give it some other sort of special stream. I was hoping that their test utility here would let me toss in IO errors and things like that. I don't see it though. Quick test IO handle. Let's go look at their mock object again. Mock object following a predefined script. Async read. This returns an IO result. Okay. This isn't quite what I need then, but I think what we've built so far is actually useful in that we can produce something that either wraps the mock object we need something very, very similar to this. We need Tokyo IO mock stuff with errors. Actions. What is actions? Actions in this case is if you have action, action equals what? Where do we get action? Oh, action is down below. Here it is. Oh, I see. HD version. Yeah, basically I really want this thing to have one more action. That's error. Do we fork Tokyo test? Do that. Maybe toss PR out there. Right here they're looking at the action. They have none. It's 0. They return 0. And I see how to actually do this. All right. Well, let's see. Where's the source for this? I don't know. Where's the repository? That's not the source. Crates.io, links. Looks like a GitHub little icon there. Oh, it's part of the main Tokyo repo. Got it. Clone or download. I guess we should fork it, huh? Alright, well, I'm not logged in with that browser to GitHub. Pop over to Chrome real quick. Fork that. There we go. Okay, so we're basically going to take this one, copy that, go back to the code, new window. Let's clone that. That's going to take a little bit of time. Oh, actually, that's not bad at all. My internet connection, honestly, is not the best. There is a fiber line about half a mile away from me. And if I give like some sort of like incredible amount of money, I could run fiber and get it for like $500 a month. It's not worth it to me. So one of the options would be to just set up an internet service provider for like my whole neighborhood, and then I'd be making money off the deal. But I don't want to do that. Okay. Spy on their lives. No, Panos, that is wrong. We do not do that. My neighbors are boring anyways. But that's not the reason why I wouldn't do it. Alright, so if we go into Tokyo test, actually how do we get this to build using the right thing? Edit cargo. Oh, this is the wrong one. Oh, not that one. This one. Cargo. Tokyo. Where's Tokyo test? Oh, test util. I thought I added Tokyo add Tokyo test. Did that somehow know to add like test utils there? Strange. All right. Paste that. Comment this out. Now for Tokyo, instead of this, I'm going to give it a path, and the path is going to be /Tokyo. And just right there should work. Cargo test. Source path. Yes, that is correct. There we go. Isn't that where we checked it out to? Okay, we do. Source Tokyo. Oh, is this not their workspace? This is a workspace. How do we point to a workspace? Let's say cat. Let's just give him cargo. That's Tokyo. Also has Tokyo test here. Not a virtual manifest instead of a package manifest. Oh, I see. So it wants Tokyo. There we go. Okay. Is it going to use the right test stuff? Sure. Macros, that's good. Not sure about Tokyo util, what it's going to want. Why did it compile Tokyo twice? The first one didn't have the path on it. Let's do Tokyo util as well, just to make sure it's not pulling in something funky. Path equal to /Tokyo util. Do we have any more Tokyo in here? That's good, that's good, that's good. Okay, that looks a little bit more reasonable. Local adder's not fail, not that, okay. Cargo build is already done. All right, we're gonna watch the test stuff. Cargo. Yeah, that's gonna be there. Now we can go over to Tokyo and add the mock.io stuff. That is Tokyo test. Oh dear. Oh, interesting. Warn on idioms. What is it? We were looking for mock. Tokyo test mock. Where's that stuff? Well, that's not big at all. Test block on. So even the Tokyo tests have tests. There's IO. Mock has inner, good. We have handle, builder, actions. Read, write. So it should be an error. Actually, I'm not sure if it should be a read error or a write error. Let's look at how their API currently works. Where were we? Back a ways. All right, Tokyo. Oh, this wasn't this one. Tokyo test, here we go. Maybe it should be read error and write error instead of just error. The next operation in the mock script will be to expect a read call and return buff. Okay. What about handle? Yeah, we'd have to put this on handle as well. Okay. I'm thinking read error and write error instead of just error. I think it's going to be important to say, oh, you couldn't do this to the right half because such and such. Let's go back to the code. Read error. And this will be what, like a standard IO error, right? Yeah, let's just kind of stamp this out. Read error, write error. A couple of those. Standard IO. Do they have error in here? No, just us. They have IO error kind. Where do they get this IO? Standard IO. Dang, they got some good documentation on this. That's standard lib, no wonder. Ah, they are pulling in IO here. So standard IO will want IO error there. Oh, does clone not work for that? Oh, that's a bummer. I'm gonna break this whole thing. We can box it. Actually, let me see. Quick. Go back to the browser. I want to see in their GitHub stuff. That's not it. GitHub. Tokyo. I want to see if anybody's actually made a PR for this. Before branches. Pull requests. I don't see anything. I'm guessing it's going to be okay. let's go back to the code and do this. So standard IO error does not implement those elements. And since it's not clonable, how much of this actually has to be clonable? Don't want to change that API though. Let's split this. Okio test. Is it build? Well, not with our changes. Yeah, Control B, colon, resize pane. Let's go 80 this time. There we go. We can see it a little better. Okay. We do that. Cargo build. Yeah. It's fine. The cargo watch. All this stuff is going to break. We can't clone builders. We can't do all that stuff. Oh, that's a bummer. I guess we could box that. We could box a standard IO error. Alright, no, because box is only clone if its internal type is clone. So we want something like RC. I don't know if there's any guarantees on this stuff being send. Just RC. Sorry, talking to my kid about how to get old video games installed on modern computers. He found I still have a boxed version of Fable.
Lost.
Yeah, Fable, the Lost Chapters. It's from a long time ago. Game of the year. But yeah, well, we might have. Let's see, it's Windows XP. It requires 256 megs of RAM. I don't know where we'll find something that small. Takes 3 gigs of hard drive space. Yeah. All right. Yeah, let's play around with that after the stream today. All right. All right. Where did? Oh, here it is. Yeah, let's get this working for us, and then I'll work at getting it merged into the other places. Okay, so non-exhaustive. Let's go to 241 then. Match actions. Sweet. So what is this? Here we're getting the action. Let's try to understand what this is. Keep the disk safe, please. Thank you. We're at 241. Where is this used? What is the purpose of this? If actions is empty, we will return none. We'll go through a loop here. Let action equal actions to pop front. What is this doing? Let's see, it looks like we're just supposed to return an action. Mutable reference to an action, okay. Self to actions, front, yeah. So what is this loop doing? If we're empty, we return none. If we have something in the first position, if it's not empty, let's see if it's a read one, and if it's not empty, we break. If it's a write one, and it's not empty, we break. It looks like we're just examining the first element there, looking for non-empty items. If it's a wait, and the time has passed, then we break. But if the time is not yet passed, we say self.waiting is equal to that, now plus duration, and then we break. So if none of those were hit, we go on to the next one. Okay. So how does read error and write error factor into this? I think we just want to break if we hit either of those because they should be handled. Read error. So if we have a read error or a write error, we just break immediately. Let's put this at the bottom. And those will be handled here. Okay. What's next? And 60. Yep, okay, never used. If we have a read, if we have a write, we need to push those things in. Sequence A. We'll expect a read call. So you can say read operation that produces an error. The next operation that mock scripts. Return buff. I see, because and return error. Read error, and this is going to be, oh, I get into insert mode. Okay, now let's do a write error. Very similar. Are there no... you can have IO errors on writes. Okay. Now I have read error, we have write. Now something that's... Oh, we need to do these as well. Okay. There's those two. Let's go to the top again. I want to make sure each of these elements gets what it needs. handle. Okay. Builder of actions. We have inner. Read error. Our builder. Build with handle. Okay, good. Handle we got. Inner. It's gonna pull an action. All right. Changing the guards next to me. Gotta clear off a little bit of the desk. There we go. So now we have this poll action, and who's calling the poll action? There's read. There's write. Okay, remaining wait action. Added those. Maybe wake up reader. Ah, there. Should do that if it is none, if it's some read, or if it's an error. Read wait. Take yourself to enter. Yeah, that looks cool. Why is this mutable? Why is this mutable action? I guess that's just the type that's being matched. I see. Action read error. Close that bracket. Good. Maybe wake up reader. Async read. Or read. If we're sleeping, sleep. If a sleep is set, it's already been fired, okay. Self to inner, read, I see. Yes, how does this work? Who calls this? Somebody's going to do an async read on this mock, and we might need to return an error in this case. So let's work in the error scenario here. Let's go down one. Just mark it for a minute. Fix me. Add read error. Okay. Sync right. Fix me. Add right error. Full right buff. Yeah, who does that? What about right error? Okay. That's source IO. Now builder here. What do we impl builder? Oh, does this not have an outline? Oh, there it is. Impl builder. Then we call build, and that gives us the mock. Okay. Look at the mock, and impl mock. We have async read and write for mock, and that's so those async read and writes. That's really where we need to focus on that. Does that get called in here? Yes, it does. Okay, so we got the wake up or the read just fine. Let's do the reader first. So when we pull for the read, where are the actions in here? I don't see actions. If we have inner to sleep, inner read. What is this? That either gives us an error. Oh, I see. So this inner read is go to inner. What's inner? Or mock inner. Is this inner? And that inner has a number of things on it. I see. Let's go look at impl inner then. Well, inner has new. It also has read on it. Oh, I see. They deleted some of this. Okay, we're gonna have to add some action. Read error. What do we want to return here? This is going to be an IO result that we're supposed to return, which should be what's actually inside of our stuff here. Oh, this is good. How does this actually inner? It has the actions. How do we pull something out of there? Pull action. I'm wondering, where do the actions? Oh, I see. That calls the match action from earlier Okay, I think I'm getting this. And that pops it off the list. Read error. Error. We will return error. Oh, I forgot the parenthesis again. Oh, but that's an RC. How do we get something out of an RC? Into? It should be owned at that point. No. What is this type here? Converting IOR from RC IOR doesn't exist. Okay, so look at the code. I'm not familiar with RC that much. I know it exists, but I don't really know how to use it. Basically, I want to take the contents out of it. Into raw. Returning the wrapped pointer. Get mutable. Raw, make mutable new. No, we don't want to drop it. From. Oh, it's pointer. Interesting. Downcast. Attempts to downcast that into a concrete. Oh, to a concrete type. What does that mean? Oh, dynamic any into a oh, no. Okay. What about cell? Maybe I should have used something else. Immutable memory location. Interior mutability. Let's see. But it doesn't actually implement clone for us. It only implements clone where T is copy. Yeah, can't use that. And if it's for interior mutability, that makes sense. Try unwrap. There we go. That's it. Try unwrap. You know what? Let's make this a little bigger. Try unwrap. See, do we return? No, that's not going to convert to the right type. good. Let's save that to error type. Wait, try and wrap doesn't work there? Oh, we have to do it the other way. Got it. RSC, colon, colon. Didn't look at the function signature. Try and wrap on error. There we go. Not move out of immutable reference. Or we could put it inside of an option. We take it out of there. Oh my goodness. Okay, so we'll do that for both of those types. Godot wants to work in our doing the RLTK tutorial for Rust. That's really cool. Oh yeah, that looks good. Oh, I got those wrong, didn't I? Okay, now try and wrap. Yes, good, good, good. Sum. Right, error. Same thing here. We're basically putting it into the sum so that we can change the option into a none by taking the value out of it. I wonder, I don't quite like it in the same line there. I wonder if we should do like let some error. Can I do it like that? There we go. I like that better. Oh, what am I doing? That's right. Where did the right arrow go? Read arrow, right. Uh-oh. Something's missing there. Oh, I didn't copy it earlier. Oh, drat. Alright. Okay. We need that back. Sequence of write operation, yank that, come back to the other panel. Sequence of write operation, good. So we have read operation, read errors. Fine. What about the other ones? I want to do the same pattern there. Just wrap up the error and then toss it in here. Read, reader. Good. Expect. Not declared as mutable. It's still upset about this. Not move out of mutable. Plug that back in. Alright, well, I've run over time, sadly. I think we're making good progress on this, though. Not move out of a mutable reference. It is moved here, which does not have the copy trait. Can I rebind it? Mutable reference? Oh, ref. Okay. Oh my goodness. Wow. That worked. Do the same thing for the right error. Right error. I don't understand why this returns an option to a mutable action when we are taking things off of that list. Actions immutable from, oh, because if it's a read and there's a buffer there, see, we might come through here twice. I see, so these might actually get operated on more than once. So really, we need to be able to signal that this is something, some underscore. There it is. Because we're going to come through here a second time. The second time we come through here, it'll be none. Because it's none, it'll fall in here and we'll get popped off the front. Yeah, that does mean that this is not exhaustive. Okay, so let's match inside of there. If let some error some something if that is some break. All right, where were we? Oh, is this still not? Cannot move out of index. Oh, ref mute. Sorry. Okay. Now we were up here. That's only going to give this to us once because we take, unwrap, expect. Yeah. No, that was in read. Okay, let's read. This one should go into write. Oh, this one's different, isn't it? What's going on here? Here we're expecting the write. write happens to get the write error. Friends. And that for loop isn't actually returning. So in this case, we need to return error. Huh. What about this up here? This here action. Why is it iterating here? I'm trying to think through this. Because here they basically take a peek at the first thing and only if it is wait do they do something. Undo some of that. So we might be able to do the same thing here. Return error, IO error. It seems like it makes more sense to have it up above. What's going here? I don't know what's going on here. If let sum self.action. So it looks like if the first thing in the list is one of these elements, we deal with the errors up front. And back here, right error, we just break out of it. To do remove right, wonder what they mean by that. All right. Remaining wait. So what's this doing here? You know what? I should probably get going. Like 50 minutes over. Well, thank you all. Fail. We're gonna raid Museum. I think these will be good changes. It'll be nice. Cool. I'll keep chipping away on that. We'll do some of that, some cleaning. See if the goat gives birth today. Until next time. Bye bye.